problems based, here we are going to perform few problems which are based on laws of set operations of part 1 under the advanced level. Now, so under these problems which are based upon the laws of set of operations, the problem number 1 is of let A comma B are two subsets of a universal set that is mu. So here we have considered A and B as two sets, the two subsets of a universal set that is mu. Then we have to prove, then show that A intersection B is equals to A minus complement of B, that is A minus B dash, then that equals to B minus complement of A, or in other words B minus A dash. So here we have to prove two conditions, that is A intersection B must be equals to A minus B dash as the first condition, and the second condition as A intersection B must be equals to B minus A dash as the second condition. Then now proof starts now. Say in our proof, so here as per the problem or according to the problem, so here A and B are the two subsets, A comma B are two subsets of universal set that is mu. Then now, but here we have to prove the condition as A intersection B equals to A minus B dash equals to B minus A dash. Then now whereas in the next logical step, so here to be proved condition is of A intersection B is equals to A minus B dash, then that equals to B minus A dash. From this it is clear that we have to prove two conditions. One is A intersection B equals to A minus B dash, then the other one as A intersection B equals to B minus A dash. So here the first one is A intersection B is equals to A minus B dash, and the second one is of A intersection B is equals to B minus A dash. But now we are going to consider the first case, that is A intersection B is equals to A minus B dash. So now we are going to prove this, that is show that A intersection B equals to A minus B dash. But here in order to prove this condition, that is A intersection B equals to B A minus B dash, first of all we have to prove two conditions, that is A intersection B must be the subset of A minus B dash, and the second condition as A minus B dash must be the subset of A intersection B. So here in order to prove the condition, that is A intersection B is equals to A minus B dash, we have to prove two conditions. The two conditions are of, here the first condition is A intersection B must be the subset of A minus B dash, and the second one as right hand side, that is A minus B dash must be the subset to the LHS, that is A intersection B. So in this case I am going to consider the first one again. So here first one is of A intersection B, the subset of A minus B dash. Since we are going to prove it by means of element wise, so we have to consider one element which belongs to the LHS set. So here the LHS set is of A intersection B, so we are going to consider the element as X. Let X be an element which belongs to the left hand side, that is A intersection B. Then now that implies X belongs to the first set, that is A. Since it is intersection, we can write it by means of AND. So here the notation of the AND is of inverted V, and X belongs to the second set, that is B. Then now, so here we got this step as per the definition of the intersection of two sets. Then now the next logical step will be of, that implies X belongs to A, and so here actually it is of X belongs to B. When we write X does not belongs, instead of belongs, if I write here does not belongs, then I have to write its complement, that is the complement of B. So X does not belongs to complement of B, or in other words it is nothing but X belongs to B. Instead of belongs to, I have written here does not belongs to, then instead of B I have write its complement, that is not in B, that is X is not in B. So complement of B. So here X does not belongs to the complement of B. Then now the next logical step will be of, so that implies, so here X belongs to set is of A, and here does not belongs to B dash, that means B dash is subtracted. So here does not belongs, X is not present in the complement of B, that is if it is of does not belongs to, so B dash must be subtracted from this set, that is A. Then now the next logical step will be of, so here then we have LHS is of X belongs to A intersection B, then that implies the right hand side is of X belongs to A minus B dash. So from this it is clear that, so here X is present in A intersection B set, and X is also the element of A minus B dash set. So here the elements which are present in A intersection B are also the elements of A minus B dash set, or in other words the elements LHS is the subset of RHS. So here we can write it as, so here therefore LHS, that is A intersection B, will be the subset of the RHS, which is A minus B dash, because the elements X is present in LHS and also in RHS, therefore the LHS will be the subset of RHS. So in this manner we have proved the first condition, that is A intersection B is the subset of A minus B dash. Then now let us consider this as the equation number 1 or the condition number 1. So in the similar manner we have to prove the second case, that is right hand side must be the subset of left hand side. So here A intersection B must be the subset of A minus B dash must be the subset of A intersection B. Then now the second one, A minus B dash must be the subset of A intersection B. Then now here in order to prove this by means of the element wise, we have to suppose one element, that is X, which belongs to the left hand side, that is A minus B dash. Then now it can be written as, so here X belongs to the first set, that is A, and so here B dash is subtracted from A, that is X belongs to A, but X does not belongs to this B dash because B dash is subtracted. So here we can write it as, and X does not belongs to, because it is of negative sign, that is minus, we have to write does not belongs to, X is not present in, so this second set, that is B dash. Then now the next logical step will be of, so that implies X belongs to A, and so here X, so instead of say here does not belongs to, I am going to write it as belongs to. Then now here, so instead of complement of B, instead of not B, we have to write only B. So here I have removed does not belongs to as belongs to, then now complement also I have removed at a time, complement and removed, and here does not belongs to is also removed. So we got X belongs to only B. Then now the next logical step will be of, that implies X belongs to, as per the definition of the intersection. So this inverted V indicates the intersection. So here as per the definition of the intersection of the two sets, we can write it as, so here A and B can be written as A intersection B. So here we got this step by the definition of the intersection of two sets. Then now, so here then we have LHS is of, so here LHS is of X belongs to A minus B dash is implies the RHS is of X belongs to A intersection B. Then now, since the element X is present in A minus B dash and the element X is also present in the right hand side set, that is A intersection B, that is the elements which are present in the LHS are also the elements of the RHS, therefore the LHS will be the subset of RHS. So in this manner we can write it as, therefore A minus B dash is the subset of the right hand side, that is A intersection B. So in this manner we have proved the second case as A minus B dash as the subset of A intersection B. Let us consider this as the condition number 2 or the equation number 2. So here from 1 and 2 equations, the first equation is of, so here A intersection B is the subset of A minus B dash, and the second equation is of A minus B dash is the subset of A intersection B. So these are of equations 1 and as well as 2. From these two, it is clear that A intersection B is the subset of A minus B dash, and A minus B dash is the subset of A intersection B. LHS is the subset of RHS, and RHS is the subset of LHS. Therefore, LHS and RHS must be equal. So in this manner, so we have proved. Therefore, A intersection B is equals to A minus B dash. So here in this case, in this manner, we have proved the first case, that is A intersection B equals to A minus B dash. Then now let us go for the second one.